So we're talking about the sum of infinite series today. So series are where you just keep adding over and over again. Actually, we're talking about infinite geometric series. Geometric means you get from one term to the next by multiplying. So if we multiply these, or if we add all these forever, what does it approach? And even though we keep adding numbers, it actually doesn't, the value is not going to get bigger and bigger like this. It's actually just going to, because we're adding smaller values over and over, it's going to kind of level off and approach something like the limit idea. So what's the limit of this series as it approaches infinite terms? Turns out it's a really simple little formula. First thing you need to do, though, is find, by the way, if you add something like, okay, what's the pattern on this one? Right, the terms are getting bigger and bigger, multiplying by 2. So what's the limit on this one going to be as you go to infinity? No.
Infinity.
Yeah, it's going to get bigger and bigger and bigger and bigger. So this only works when you're adding values that are less than 1. I mean the ratio is less than 1. So when the values get smaller and smaller, this one you're just adding larger and larger values. It's just going to get bigger and bigger, bigger, faster and faster. But if you add smaller and smaller values, it's going to stop going up, or it's not going to go up as fast. It's going to kind of level off. So the ratio for this to work, if the ratio is bigger than 1, like the ratio on this one is 2, common ratio, because it's multiplying by 2, it's going to get bigger. But if the ratio is less than 1, what's the ratio on this one? 1/2. So how do you get from 1 to 1/2 times half, times half, times half, times half? So the common ratio on this one is just 1/2. And this one is going to taper off. It's not going to go to infinity.
0.
And the formula is tiny. It's t sub 1 over 1 minus r. Simple, easy peasy. If the ratio is less than 1, this works. Okay, what did t sub 1 stand for?
First term.
First term. So in this case, it's a 1. So that's it. Now, 1 minus 1/2 is 1/2. 1 divided by 1/2 is like 1 times 2. So this is 2. So this value is approaching 2. 1 plus 1/2 is 1/2, plus 1/4 is 1 3/4, plus 1/8 is 1 7/8, plus 16. It just gets closer and closer to 2 as time goes on. I think I actually did. That might have been number 1. Yeah, that's because, yeah, okay. It's like the easiest example, so that's why I chose it. That's why they chose it. Okay. All right, what is the common ratio? How do we get from 24 to negative 12 to positive 6 to negative 3? What are they multiplying by? Or dividing by, you could say. They're dividing by negative 2, or you could say they're multiplying by negative 1/2. Okay, dividing by 2 is like multiplying by 1/2. Since it's alternating between negative and positive, we're multiplying by a negative. So t sub 1 is, okay, the formula, t sub 1 over 1 minus 1. T sub 1 is 24. Oh, sorry, I forgot my negative. I was going to say that doesn't make sense. Okay, so 1 minus negative 1/2 is like 3/2, or 1/3. 16? Yeah. Bum, bum, bum. Okay, how do you get from 5 to 5 times blank? 5 times what equals 5 to the negative 1? If there is no exponent on the 5, what exponent is on the 5? Right. So how do we get from, what do we multiply to 5 to turn into 5 to negative 1? You guys know what, or you could say, what do we multiply 5 to the negative 1 by to get turned into 5 to the negative 3? Yeah. So when you multiply, remember the same base, you add the exponents. So it would be 5 to the negative 2. If you're not sure, like 5 times n equals 5 to the negative 1, how would we solve this? Like algebraically. 5 times what equals 5 to the negative 1? What would you do to solve this?
5 under 6.
You divide by 5, right? So if you want to know what this times what equals that, you just go backwards. This divided by that will give you the common ratio. Or this divided by that will give you the common ratio. Okay, anyway, it's 5 to the negative 2. Do you guys know what 5 to the negative 2 is worth? Or 5 to the negative
0, 4.
Okay, it's worth 5 squared upside down. So it's like 1/25. Either way, it doesn't really matter what you use. So t to the 1, t sub 1 is 5 over 1 minus one of those two. It's kind of messy. Seven, t sub 1 plus t sub 2, t sub, okay, well, that doesn't tell us anything. T sub n equals 8 times 5 to the negative n. T sub n, okay, this number's 5 to the negative n. Okay, so might help if we like figure out what this is. So